Hello, my name is James Watson. You can see my email address up here on the screen in case you want to contact me or if you have questions about this video. Today we're going to be covering some basic computing concepts, starting with variables. Now, for whatever program that you're writing or whatever problem you're going to solve, you're going to need data to model that problem. And we need places to store that data. Types of data you may need to solve a problem are types of numbers, such as integers or decimal numbers, strings or text, and or lists of numbers. A couple of problems or programs you might want to solve is, for example, if you had a game with a character, they might have integer hit points and magic points. Also, you might have a bank account, and that bank account is going to have an owner whose name appears as text, and they're going to have a balance in dollars that's represented with a decimal number. So these values can change over time. Obviously, it wouldn't be a very fun game if there was no possibility of losing, and your customers are going to be upset if they make a deposit in the bank account and their balance doesn't go up. So that's why we call them this idea of storing numbers whose value can vary, a variable. And so we're going to consider a variable a named placeholder for a piece of data that has significance for your problem. And so there's two parts to a variable. The first is the type. You'll be covering types later in this class, but various types you might need are integers, which are just the natural numbers 0, 1, 2, 3, 4, and including the negative natural numbers. Decimal numbers with some fractional component. We call those floating point numbers. Strings of characters or text. Boolean true false, or just a single character like A, B, or C. And so the type you're going to pick is going to match the type of problem that you're trying to solve. The second part, just as important, is its name. You should name your variables something short and descriptive that's going to help yourself and others understand your code. So and also an important point is that once you set the type of variable, the data type, that type doesn't change in C++. In C++, the type doesn't change. In some other dynamically typed languages like Python or MATLAB, the type can change, but not in this class. And so this value can change over time. So for example, if we look at our pseudocode examples here, that we could have x equal to 4, or we could just write it in a more text-based way in pseudocode, set account balance to $4, set number of dogs to 1,000. These are all acceptable pseudocode statements, I guess you could call them, for assigning a value to a variable. One of the points of writing software is that it's solving a specific problem, but the specifics of your problem may change between each time that you run this piece of software that you're writing. So it's important that your program be able to receive and respond to input. Otherwise, it's going to be static. Otherwise, it's going to produce the same It's going to produce the same results each time unless we're giving it different input. So different possible ways we might enter input is entering text at the terminal through the keyboard, reading from a file that's somewhere on your hard drive, receiving data over a network, collecting data from sensors in the case of a robot. So you might represent input with some statements such as the following in your pseudocode. And also, so it's also important that we know what the result of our program's activities are. And so we need to utilize output in order for the robot, the program to report back the results of its working, the results of its operation. So we can send output back along all the avenues that I was just talking about, that you could also write text to the screen in the same terminal where you entered it. You could your program could create a new file or write to an existing file and put its output there. You can send data over a network. In the case of a robot, you could have some sort of mechanical response to input, like something you'll be learning about partway through the semester is cout and cin, which are the two statements you'll be using the most for text input and output to the terminal on the screen. So the next topic we're going to talk about is conditional statements or conditionals, which are important because we don't want our program just to be, a laundry list or a to-do list of things that happen in the exact same way every single time that we run a program, every time that we run our software. In order for our program to be smart and act on our behalf, we're going to have to give our program some decision-making power. If we extend our examples from before, in the case of the game character, HP is kind of HP or hit points is traditionally kind of a marker for, how well you're doing and how healthy your character is. And if it reaches 0, that's equivalent to death. So we're going to end the game if the character's hit points ever reaches 0. Likewise, we're not going to allow your game's character to cast a spell unless his magic points are above 5. And on a more serious note, for our bank account, we're only going to allow the user to enter letters, from any language as their name. And we might also want to offer the user some warning if their balance gets too low so that they don't overdraw. And so conditional statements or if statements are used if we want to take some action only if some condition is met. And so we want some code to run if that's true. And if that condition is not true, then we just ignore all that conditionally executed code. And ultimately, we can provide another block of code that only runs if that condition is false. And so conditional statements are a type of a larger group of statements we call control flow statements. And control flow statements are any statement that modifies the normal flow of execution of code. So normally, code is going to be executed line by line from top to bottom in kind of a to-do list type fashion. But anything that modifies that behavior, that top from beginning to end behavior, is what we call a control flow statement. And so just a style note here for a pseudocode is that when we write if statements in pseudocode, that we want to indent everything that's going to be executed conditionally. So if you say if x is smaller than 5 and you have a whole list of things that should happen, only if x is less than 5, then that whole list of things that should happen, all those pseudocode statements, should be indented, either 1 tab or 4 spaces over, depending on your editor, from the surrounding code. And so also with our if statements, we have an if branch and an else branch. And we call them branches because if I could just make a diagram here. So if we had some conditional x is less than 5, that if it's true, we follow one edge of the diagram. And if it's false, we follow the other branch of this tree-like diagram. And so that's where the term branch comes from, is that we have, if we're to diagram it out, that things that happen on the true side and the things that happen on the false side can be separated into these separate branches in our tree diagram. And so that indented collection of statements is called a code block. And so a code block is just a collection of statements grouped for some common purpose. And for the sake of clarity, we're going to indent the entire block. So I have an example pseudocode if-else statement. And so if I say if var1, if var1 is my variable name here, is less than 5, I'm going to add 5 to var1, and then I'm going to print var1. So those are two separate statements that are happening in response to var1 being less than 5. And so I've indented this code block. And so this entire block of statements here, this collection of two statements, is going to happen in response to var1 being less than 5. I also have an else branch with its own block. And so all of these statements right here that I have my cursor by right here are only going to be executed if var1 was 5 or greater. So next we're going to talk about loops. So we might have a large collection of data to operate on, like a list of numbers of all the same type or a list of names. And so typically we're going to have some work to do on each of these separate items. A loop is a control flow statement that repeats a block of code, either conditionally or a set number of times. And so something that we're going to talk about very briefly two types of loops, but every type of loop has a loop body, which is the loop's own code block. And that code block is executed every iteration. And an iteration is just a term that we use to refer to one full execution of that code block. So a for loop is a loop that runs some set number of times. We don't have to know before the program runs how many times it's going to run. We can set that number of times it's going to run at runtime in response perhaps to user input or to some file that we're reading. But we're going to have some loop bounds in our pseudocode here. So we have, in this for loop, we're saying for I equals 1 to 10. And here, I is our loop variable, or our counting variable. And so at the top of the loop, I is going to be set to each of these numbers within the loop bounds in turn. So it's going to be set to I equals 1, I equals 2, I equals 3, all the way up to I equals 10. And it's important because we can use this name, this variable I, inside the loop. This is a special variable that only exists inside the loop. And so here we're going to print the square of I is, and then we're going to print I squared. And I is going to change, and so this is going to print out the square of each of these natural numbers from 1 to 10, 1, 4, 9, 16, all the way to 100, which is 10 times 10. Another type of loop is a while loop. And so we're iterating some indeterminate, possibly indeterminate number of times based on some loop condition. So this is somewhat similar to the situation of an if statement, where we have some conditional expression, some Boolean expression that we're going to evaluate at the top of each iteration. And we will only execute that iteration. We will only iterate if that conditional statement is true. And so something that, for some reason, this class, because of the similarity to an if statement, some people call an if statement an if loop, and an if statement is definitely not a loop. So just make sure you understand the distinction between an if statement and a while loop. So what the while loop imposes some extra bookkeeping on us in that the loop must modify values related to the conditional so that our conditional eventually it evaluates to false. Otherwise, we have an infinite loop situation where the loop condition is always met, which means that we'll iterate forever. And depending on what's happening inside of your loop, your program may become unresponsive. You may have some infinite printing going on. If that loop uses up memory, then all your RAM might be completely consumed, and causing your computer to crash, or at the very least freeze. And so we don't want infinite loops because it might cause the program to behave in ways that's detrimental to the work that we're trying to do. So you could express a while loop in pseudocode in the following fashion. Our condition is while n is not equal to 1. And so that's a loop condition. N is not equal to 1. So any other for when n assumes any other value other than 1, then we're going to iterate. We're going to run that loop body. And so here, we're illustrating a point that I made earlier, is that we can nest code blocks, right? We can put an if statement inside this loop body. And so we test if n is even, we run a conditional here, and if n is even, we're going to set n equal to n over 2. Else, if it's not even, if it's odd, we're going to multiply n by 3 and add 1. And we're going to just print n after that iteration has completed. We're going to talk about functions. And so it's important for you to understand it's a fundamental of programming. Don't worry so much about the syntax specifics of functions. We'll be talking about that at length. Just know sort of the basic setup of what a function is. So why would we need functions? Because we might have in our problem-solving activities some subproblem that needs to be solved over and over again. And so once we figure out how to solve that subproblem, you might have a mini procedure or some algorithm that's used within some larger algorithm. It would be tedious to write that algorithm or write that code over and over again every time we have to solve that subproblem. We already solved it. Why solve it over and over again? Instead, it would be nice if we had some reusable block of code that we can deploy anytime that we're going to solve this subproblem. And so a function fits this description. It's a named block of code that operates on parameters and returns a desired result. And another name for a function is a procedure. So the principle here is we write a function once and use it many times. And we call it by its name. We have to name the function. Some parts of a function are the parameters. Those are the named variables that we pass to the function that are used inside the function code block. We have arguments, which are the actual values associated with those parameters. We pass it. Those are passed to the function by the code that calls the function. The function has a return value, the result of the function's calculation, the result of the work that the function does, in other words. And that value has a type, because the type has to match the expression where we're using this function. So a pseudocode function might be just the word function followed by the name of the function. You don't have to use the word function. You could use the word procedure, or you could abbreviate it, just some way of showing us that you're getting a function here. The function name, its parameter list. And so this is similar to these parameters, these names in between these parentheses here, are names that only exist inside our function. It's similar to our loop variable that we saw above, that we're naming these parameters something, and they mean that something, they have significance, or scope, we call it, inside the function only, but do not exist outside the function. And so here's a C++ example that does the same thing as a pseudocode that you might, just might be useful to look at. So that concludes this video. Again, here's my email address if you have questions, or you can obviously ask your TA or your instructor. Have a good day.